Good day everyone and welcome to another edition of Sentinel V training video. My name is Wilbur Rattoni and I'm one of the field service engineers for Teledyne RD Instruments located in Poway, California, USA. In this video, I would be discussing the major components of a Sentinel V. So let's start. The first major component is the transducer head, or simply the transducer. As you may already know, or as you will find out, Sentinel V is available in three frequencies: 300 kHz, which is also called V100, 500 kHz, which is also called V50, and 1 MHz, which is also called V20. The V100 has a transducer head which looks like a clover leaf, like this, while the V50 and V20 Sentinel Vs have a transducer head that looks like this. Please note that you cannot differentiate between a V50 and a V20 easily just by looking at the transducer head. The only way to tell is either by looking at the labels or by communicating to the Sentinel V through Ready V, which is a different topic. Furthermore, there's also a 4-beam and a 5-beam transducer configuration. What you see in the picture is a 5-beam transducer configuration. For the 4-beam transducer, you just imagine the middle beam or the 5th beam, which is this, not being present. The 5th beam is also referred to as the vertical beam. As to what the purpose of the vertical or the 5th beam is, that's for another discussion and will be discussed in one of our Sentinel V training videos. The next major component is the housing. There are 3 different housing variations for the Sentinel V. These are Sentinel V with a standard pre-assembled battery pack, Sentinel V with loose or off-the-shelf commercial batteries, and the direct read or externally powered Sentinel V. A Sentinel V with a standard pre-assembled battery pack uses a pack of 36 D-cell alkaline batteries in series, physically configured as 3 stacks of 12 cells that supplies a nominal voltage level of 18 volts DC. It is the tallest of the 3 configurations. It has a height of more or less 465 millimeters or about 18 inches roughly. Please note that the pre-assembled battery packs are shipped inside the systems but not connected. A Sentinel V with the D-cell or off-the-shelf commercial battery configuration uses 12 D-cell alkaline batteries in series that provides a nominal voltage level of 18 volts DC. It has a height of more or less 350 millimeters or about 14 inches roughly. Please note that Sentinel V with this configuration are shipped without the batteries inside the system. Finally, there's the direct read configuration. This configuration obviously does not contain any battery. Hence, it is the shortest of the configurations. It requires external AC power adapter, which is also supplied by RDI, and it has a height of roughly 6 inches or so. Now let's take a closer look at the off-the-shelf battery housing. When you open the battery housing, the battery compartment looks like this without the D-cell batteries. This picture shows the loose battery housing with the D-cell batteries but without the top cover. While this third and last picture shows the battery compartment with the D-cell batteries and the top cover. The proper assembly and installation of the batteries are discussed in one of our Sentinel V training videos. The next major component is the end cap. There are 2 variations of end cap: an end cap without a connector and an end cap with a connector. The optional end cap connector has two variations as well: an end cap with a right angle connector and an end cap with a straight connector. What end cap is more appropriate depends on your application and requirements. The next major component is the RDI provided power supply or power cable. If the Sentinel V is configured with the optional end cap connector, then external power can be used. The optional AC power adapter provides 18 volts DC, with an input voltage of 100 to 240 volts AC. To conserve battery power, you may use the power cable when testing or experimenting with your Sentinel V while you're in your lab. Again, the AC adapter provides 18 volts DC. If this input voltage is greater than the battery voltage, then the ADCP will draw all power from the AC adapter, even if the battery is installed and connected. The next major component is the I/O cable, or the underwater Y-mold cable with 8-pin connector. The I/O cable has 3 terminals, so to speak. The first terminal is the one that you connect to the end cap connector of the Sentinel V, if your Sentinel V is configured with an end cap connector. The second terminal is the one that you connect to the RDI provided AC power adapter. And the last terminal is the serial terminal that you will use to connect to your PC or laptop. We have discussed the 3 major components of a Sentinel V thus far, namely the transducer, the housing, and the end cap. Now let's get into more detail and let's take a look at the other major components of the Sentinel V. Let's start at the transducer head. At the transducer head, we will find the beams. Again, the 5th beam or the vertical beam, which is the one in the center, is optional. And then there's the pressure sensor, which the Sentinel V uses to measure transducer depth and has a standard rating of 30 bars. And there's the temperature sensor, which along with the depth and salinity values the Sentinel V uses to estimate the speed of sound. Unlike the older generation workhorse ADCPs, the pressure sensor and the temperature sensor come as standard with the Sentinel V. Now let's take a look what's in the end cap. In the end cap, we will find the touch sensor and the connector. If present, as we have mentioned, the connector is optional for a Sentinel V. We use the touch sensor, which is this, to wake up and to initiate wireless communications with the Sentinel V. How to set up wireless communications with the Sentinel V is another topic. We use the connector, which is this, if we want to power the Sentinel V using the RDI provided power supply. We have so far discussed the external components of a Sentinel V. Now let's move on to the internal components. Inside the body or housing of the Sentinel V, we will find the board stack. Normally, there shouldn't be any reason for a user to access the board stack unless perhaps instructed by Teledyne RDI field service or an RDI technical representative. The board stack contains the PIO DSP board, the Tranceiver board, and the EMI shields. Unlike in the workhorse, the PIO and the DSP circuitry are contained in a single board. In the next slides, we will look at each of these components in more detail. The PIO DSP board contains important components, such as the compass, the micro SD card, For workhorse users, you will note that the workhorse uses up to 2 PCMCIA cards for a maximum size of 4 GB total. The Sentinel V uses a micro SD card with a memory of 16, that's 16 GB. There's also the debug port, which is this, and the Ethernet jack. These are normally used by RDI personnel for debugging and troubleshooting purposes. There's the wireless module. And finally, there's the main power and serial port. Now let's take a closer look what's under the transceiver board. The transceiver board contains important components such as the receive transformers and transmit transformers. It also contains sensor connectors such as the pressure sensor connector, temperature sensor, beam corrections, and the transmit capacitor. Inside the transducer head are the beams, beam mounting hardware, and the sensors. One special characteristic of the Sentinel V from a hardware standpoint is that it has a replaceable transducer pucks. This means that if, for any reason, one of the transducer beams is damaged, when you send it back to us for repair, we don't have to replace the entire transducer head, like how it is for the workhorse. Before I proceed, I would just like to note again that more often than not, there shouldn't be any reason why a Sentinel V user would be accessing these components. This is just strictly for your information. Another major component of a Sentinel V is the external battery. The optional external battery case holds 2 pre-assembled battery packs for a nominal voltage level of 18 volts DC. This is used as a backup power by connecting it to the Sentinel V. This is done in cases when the user wants to do a deployment for an extended period of time. The next major component is the dongle or the license key. Although the dongle or license key is not a part of the Sentinel V's hardware per se, you will need to install the license key in a USB port in your laptop or PC to save processing changes, save images, exporting, and to enable printing in Velocity. If the license key is not installed, you can still use Velocity to view files. However, Waves processing requires a Waves-enabled license key, which is another topic. What is Velocity, how to export data, and how to view and process data are all different topics as well.